So we figured out when using the graphing method that while that's okay, it has its problems. And most of the ones that we looked at, they had a nice place where they intersected. But what if you have like fractions or decimals, or what if your graph goes way off the graph board? And that happens a lot. We have other methods. The first method we're going to look at is the substitution method. Now, the steps to these are at the top of your guided notes if you're using those. If not, you might want to pause this and make a copy of these, because I'm going to have to erase them so I'll have plenty of room on the board. But these are your steps. Remember, you're going to have two equations with two variables. So the first thing you're going to do is solve one of the equations for x or y. Then you're going to substitute that into the other equation, and this will become more clear when we start applying these. Then you're going to solve, and then substitute and solve. So you can see from your steps, it's solve, substitute, solve, substitute, solve. That should make it easier to remember. So, okay, like I said, if you don't have guided notes, take a minute and pause this and copy these down, and I'm going to erase them and get us a problem. So let's look at problem number 7. We have two equations, y is equal to -7 minus 1 and y is equal to x minus 9. You're going to pick one of the equations and solve it for x or y. Now, fortunately, in this first example, both of these equations are already solved for y. That's what it means. Get one of the letters all by itself. So this one, we're not going to have to do step 1. We can just pick either one we want to. I'm going to pick this second equation and I'm going to substitute it into this equation up here. So where there's a y, I'm going to put x minus 9. And what that's going to give me is x minus 9 equals -7x minus 1. All right. Now your next step was to solve. So that's what we're going to do, just using the steps to solving equations. I would subtract, well, let's add 7x to each side. So now you have 8x minus 9 is equal to -1. Add 9 to each side. So now you have 8x is equal to 8. Divide by 8. X is equal to 1. Now that is the first number in your coordinate pair. Sometimes you find x first, sometimes you find y first. Now we found x, so that number goes in the x position. Now you take that number back up into either equation you want to, and we're going to substitute it in for x, and then we're going to solve. Once again, let's use the bottom equation since it's a lot simpler. So we're going to do y equals, we're going to substitute 1 for x minus 9. And pretty simple. Y is equal to -8. So that's your ordered pair. And that is much better than trying to graph both of these and find a connection point. Okay, let's look at another problem. Problem number 8. We have these two equations. Our first step is to solve one of your equations for one of the variables. And fortunately, this time one of them is solved. This top equation is already solved for y. So all I have to do is take this expression here and substitute it into the other equation for y. So that's what this is going to look like. It's going to be 7x plus, now when I substitute this in, that's 3 times -5x plus 30 equals 42. Now you can see what this step actually does is it eliminates one of your variables. Now you have a linear equation in one variable and you can solve that. So let's go to it. 7x. All right, when I distribute the 3, I get minus 15x plus 90 equals 42. All right, combining terms, 7x minus 15x is -8x plus 90 equals 42. I'm going to subtract 90 from each side, and that's going to give me -8x is equal to -48. Divide both sides by -8, and x is equal to 6. So as far as my ordered pair goes, I just found x, so I'll put that here. Now you take this number back up into either equation and substitute it for the x. I'm going to choose the top one. So now I have y is equal to negative 5 times 6 plus 30. Y is equal to negative 30 plus 30. Therefore, y is equal to 0. Now remember, don't freak out when you get a 0. That's a perfectly legitimate number. And this is our ordered pair. Now if you want to check them, you can substitute these two numbers back in to both of these equations and they should make a true statement. Okay? Let's look at number 9. And for number 9, here's our two equations. So step 1, we're going to pick one equation and solve it for one of the variables. Now, any of it works. You can choose either equation, you can choose x or y, but sometimes you need to make smart decisions. Look at your 4 choices. I've got 2 x's and 2 y's. If you have one that does not have a coefficient, that's going to be the easiest one to solve for. So we're going to take the 7x plus y, since it has just a y, and let's solve it for y. All right, so trying to get rid of everything attached to the y, I'm going to subtract 7x from each side, and that's going to give me y is equal to negative 7x plus 22. And that's the end of step 1. Now I'm going to take this into the other equation. Now here's what that means. I just used this equation. So I'm going to substitute it into this equation for y. So what I'm going to have is 6x minus 5 times, and here's where the substituting comes in, negative 7x plus 22 equals negative 28. Okay, so let's solve. 6x, now when you distribute minus 5 times minus 7x, that's going to give you plus 35x. Minus 5 times plus 22 is going to give you minus 110 equals negative 28. All right, 6x plus 35x is going to give you 41x minus 110 equals negative 28. And then we would add 110 to each side. So now you have 41x equals 82. Divide both sides by 41, and x is equal to 2. So here's the first number in your ordered pair, 2. Now to find the y, we go back up here into either equation and we're going to substitute that in again. I'm going to pick this one because it looks a little simpler to solve, but they'll both work. And I'm going to substitute this 2 in. So now I have 7 times 2 plus y equals 22. 14 plus y equals 22. Subtract 14 from each side, and y is equal to 8. And there's our y. So that's going to be your answer there. Let's look at another one. Okay, let's look at number 10. Here's your 2 equations, both have an x and a y. Step 1 is to pick one of your equations and solve it for one of your variables. Now from the tips I've given you, you should realize solving for this x right here is going to be your quickest bet. So let's take x minus 7y equals 53, and we're going to solve it for x. And all that's going to amount to is adding 7y to each side. So now you have x is equal to 7y plus 53. All right, now we're going to take this value. We solved this equation. So now we're going to use this equation. We're going to substitute this in for x. So that's going to give us negative 4 times, all right, 7y plus 53 minus 5y equals 19. Okay, and then we're going to distribute, so that's going to be negative 28y plus negative 4 times 53 is 212, negative 212. minus 212 minus 5y equals 19. Now, combined terms, negative 28 minus 5y is negative 33y minus 212 equals 19. Add 212 to each side. Negative 33y is equal to 231. And then divide both sides by negative 33. And y is equal to negative 7. Okay, that gives you one of the numbers in your ordered pair. Now, since we found y, that goes in the y position. And the only thing left to do is plug this in to either equation. I'll pick this top one. If you plug negative 7 in, that's going to give you x minus 7 times negative 7 equals 53. Negative 7 times 7, that'll give you x minus 49. And since it's negative times a negative, that will change to plus 53. Subtract 49 from each side. And you have x is equal to positive 4. Once again, you really should plug both of these numbers in and check your work. Okay, let's look at number 11. We can choose either one. You know, this one doesn't have a coefficient, but it does have a negative sign. Let's just go ahead and take the top one and we'll solve it for y. It's not going to be that difficult since the only thing is that the y has a coefficient of 2. But since both of these other numbers are even, it's going to be an easy solve. Let's divide all the way through by 2. So now you have y is equal to 3x plus 5. Now you're going to take this expression into the other equation, which is this one, and we're going to substitute that in for y. So what that's going to give us is 3x minus, all right, substitute this in, 3x plus 5 equals 5. Now when we get rid of the parentheses by distributing this negative sign, we're going to have 3x minus 5 equals 5. All right, 3x minus 3x is 0. We're just simplifying. And right here we end up with negative 5 equals 5, which is not a true statement. So what you have here is a solution of the empty set. There is not anything that will fit both of these equations. Okay, let's look at one more. Okay, let's look at number 12. We have two equations, two variables, and we're going to solve by substitution. So we're going to pick one of the equations and solve it for one of the variables. Now, I'm actually going to pick the second equation and I'm going to solve it for y. So I'm going to take 4x minus 3y is equal to negative 5. And then I'm going to subtract 4x from each side. Remember, you're not technically solving the equation, you're just rearranging it, you're manipulating it. So now I have negative 3y is equal to negative 4x minus 5. And then we're going to divide all the way through by negative 3. So what we're going to have is y equals 4/3 x plus, because negative over negative is positive, 5/3. Now we're going to take this expression into the other equation up here and we're going to substitute this in for y. So I'm going to have 5x plus 7 times 4/3 x plus 5/3 equals negative 17. And this is not going to be fun, but it's not going to be hard. All right, when we distribute this 7 into here, remember when you multiply a whole number times a fraction, it's actually 7/1. You're just multiplying the whole number times your numerator. So 7 times 4 is 28 over 3x. And then 7 times 5 is 35 over 3 equals negative 17. Now, what I'm going to do, because I'm not fixing to fool with these fractions forever, let's just get rid of them. Let's just multiply all the way through by 3, and that's going to turn everything to whole numbers. So when I multiply this whole equation through by 3, I'm going to get 15x. 3 times this fraction, the denominators cancel out, so I just have 28x. 3 times this fraction, the denominators cancel out, so I have plus 35. Now, 3 times the other side gives me negative 51. All right, 15x plus 28x is going to give me 43x plus 35 is equal to negative 51. Then I'm going to subtract 35 from each side. So now I have 43x is equal to negative 86. Divide both sides by 43. And x is equal to negative 2. So this is the first number. This is the x coordinate. So it goes in the x place. Now all I have to do is take this negative 2 back over here wherever I want to. I'll just fill it into the first one. So I'm going to have 5 times negative 2 plus 7y is equal to negative 17. So I've got negative 10 plus 7y is equal to negative 17. Add 10 to both sides, and you get 7y is equal to negative 7. Divide both sides by 7, so y is equal to negative 1. And that's it. Like I said, you should plug them back in to make sure they work. Okay? So, good luck with your homework problems now.